So now we can start to come up with different classifications of energy if we examine work done in different scenarios. The first scenario is we'll assume we push on an object in a certain situation where the only first force acting on the object is our push. So in that case, this would be our object. The free body diagram would only include the force of our push. In that circumstance, we would expect, since there's only one force acting on the object, that there would be a net force acting on the object. And that net force would just be equal to the force of our push. And since Newton's second law still applies, we know that any object that experiences a net force will accelerate via F net equals ma. Okay. Well, that means we can describe the force in terms of what it does, which is m times a. During this time, the object would displace. So if there was some delta t over which we did this, then we would get some delta x associated with that. How would that work? Well, let's say the object was initially at rest. We have an equation that tells us how displacement relates to time and constant acceleration. And it works like this. Right? So what that means then is if we know the period of time or some other kinematic quantity, we could know what the displacement would have been, meaning we could calculate work. Work done by our push would end up being equal to, and if you did the kinematic math, that's just going to be F push times delta x. Those will necessarily be the same direction in this case, since there are no other forces. So if the object was initially at rest for this situation, then if we pushed it to the right, it would accelerate to the right, and it would therefore displace to the right as well. So I wouldn't need the cosine theta here. And then in this case, F push is equal to ma. And to calculate work, I multiply that by delta x, and I know then that delta x could be related back to the acceleration and whatnot through, for example, if I knew the amount of time that passed. And the long story short then is if I deal with the kinematics to put this in terms of a common kinematic variable, I can describe this ma times delta x here for this scenario as ultimately being equal to 1/2 m delta v squared. Right? So that must be equal to a change in energy if we assume that we were external to the system where the system is the object, then our force exerted work on the object that must have changed the energy of the object. This is a specific type of energy then. In this case, when you do work and there are no restoring forces to overcome, that work will create kinetic energy. That's the energy of motion. And kinetic energy, which I will use a K for, is just equal to 1/2 the mass of an object multiplied by the speed with which it's moving squared. So that is one flavor of energy.